Good morning, friends. After the discussion of total energy and also the radius of nth orbit of an atom, and also we discuss about the total energy of electron in nth orbit. Now we are going to start our discussion about the energy levels and also what is the ionization and excitation energy of the hydrogen atom. So question is that what is the ground state of an atom and what is the ionization energy and excitation energy of hydrogen atom? We know that the total energy of electron in nth orbit of an atom En is equal to minus m z square e raised to 4 upon 8 n square h square epsilon 0. Now this is substituted the value of mass of electron, charge of an electron, h Planck's constant and epsilon 0. We obtain the total energy of an electron in nth orbit is minus 13.6 into z square upon n square electron volt. That is the total energy of electron in nth orbit for any element in electron volt. Here the negative sign indicates that as the value of n increases, here the value of n, that means the number of orbit increases, or in other words, as we go away from the nucleus in an atom. So what's happened? The negative En decreases, therefore negative value of total energy decreases. It means the energy of an electron increases gradually in far orbit from the nucleus. Already we know that there is the nucleus, but this is the positive charge. These are the orbits, different orbits of the nucleus. As we go away from the nucleus, so the number of orbit increases, therefore the negative value of energy decreases, and hence the total energy of an electron increases gradually as we go away from the nucleus. Again, the total energy of electron in atom En is equal to minus m z square e raised to 4 upon 8 n square epsilon 0. It is substituted the value of mass, electron, charge of an electron, Planck's constant and epsilon 0. We obtain the energy in electron volt minus 13.6 into z square upon n square. Here the negative sign indicates that as the value of n increases, the negative value of total energy decreases. It means the energy of an electron gradually increases in far orbit from the nucleus. Now, when the electron is revolving in orbit closest to the nucleus, that means first orbit, the energy is smaller. Its value is minus 13.6 for hydrogen atom. Such low state of an atom is known as the ground state. That is known as the ground state. What is the ground state? When the electron is revolving in an orbit closest to the nucleus. That means the n is equal to 1. The energy is smaller. That means the minus 13.6 electron volt. Such low state of an atom is known as the ground state. That is known as the ground state. Again, the definition of ground state: when electron is revolving in orbit closest to the nucleus, that means the first orbit, the energy is smaller. For hydrogen atom, minus 13.6 electron volt, while other element minus 13.6 into z square electron volt. Such low state of an atom is known as the ground state. Clear? Okay. The energy of electron orbiting in orbit of Bohr radius. Bohr radius, that means for the first orbit, this orbit. N is equal to 1. Having the radius is equal to Bohr radius. So energy E1 is equal to minus 13.6 z square electron volt. For hydrogen atom, Z is equal to 1, therefore E1 is equal to minus 13.6 electron volt. Thus, the minimum energy required to free the electron from the ground state of H atom is 13.6 electron volt, is known as ionization energy. After the definition of ground state, what is the ionization energy? For that purpose, the energy of electron orbiting in orbit of Bohr radius, that means the energy of electron in first state, n is equal to 1, is E1 is equal to minus 13.6 Z square electron volt. For hydrogen atom, Z is equal to 1. Therefore, for hydrogen atom, the minimum energy of electron in first orbit is minus 13.6 electron volt. Thus, the minimum energy required to free the electron from ground state is 13.6 electron volt, is known as the ionization energy. To remove the electron, that means the positive ion is increased in an atom. So how many minimum energy is required to remove the electron? That is known as the ionization energy. Clear? Now we are going to discuss about the excitation energy. For that purpose, how the electrons are excited in atom. When the electron get the energy due to the any process, due to the increase in energy, the electron is excited and change its state according to its energy. Now, when an hydrogen atom receives the energy, the atom acquires the sufficient energy to raise the electron to higher energy state. The atom is said to be in excited state. That means when the hydrogen atom receives the energy, the atom acquires the sufficient energy to raise the electron to higher energy state. Right? In this condition, the atom is said to be in excited state. The energy required to excite an electron in hydrogen atom to its first excited state, n is equal to 2. n is equal to 2. n is equal to 1 is the ground state. n is equal to 2. There is the quite higher energy level, that is known as the first excited state. So how much energy is required by the electron to make the transition from ground state to the first excited state? That means n is equal to 1 to n is equal to 2 state. Therefore, the energy difference between these two energy levels, E2 minus E1, is equal to minus 13.6 upon n square, that means the 2 square, minus into bracket minus 13.6 upon 1 square. That is the energy of second energy level, that is the energy of the outside. Okay, so this negative becomes the positive, that is the 13.6 electron volt, that is 13.6 by 4. So as we make subtraction, we obtain the 10.2 electron volt. So energy required now, there is a 10.2 electron volt energy is required to excite the electron from ground state to the first excited state. After getting that much energy, the electron reaches to the first excited state from the ground state. Now, the energy required to bring an electron from ground state to second excited state, that means the n is equal to 3, is E3 minus E1. That means the energy difference between these two energy levels. So E3 minus E1 is equal to minus 13.6 upon 3 square minus into bracket minus 13.6 upon 1 square. So 13.6 minus 13.6 by 9. Then 13.6 minus 1.51 is equal to 12.09 electron volt. So that is the energy required to make the transition of an electron from ground state to the second excited state. That means, yes, we give the energy to the electron volt equal to the 12.09 electron volt energy to the electron in ground state, so this electron reaches to the second excited state. Similarly, the energy required to bring an electron in third excited state, fourth, and also infinite excited state are 12.75 electron volt, 13.06 electron volt, and 13.6 electron volt respectively. Thus, the minimum energy required to excite an electron from the ground state is known as the excitation energy. Again, the minimum energy required to excite an electron to the higher energy state from the ground state is known as the excitation energy. While the ionization energy is that to remove, to make the free electron from the ground state. Right? So, minimum energy required to free the electron from the ground state is known as the ionization energy. Again, in excitation energy, how the electron make the excite from the ground state? Generally, in stable atom, all the electrons are in ground state. Right? When this electron gets the energy due to the any process, so electron get the energy and then becomes the excite and reaches to the higher energy level according to gaining the energy. When the hydrogen atom receives the energy, the atom acquires the sufficient energy to rise the electron to higher energy state. The atom is said to be excited state. Now here we are going to discuss about that, how the electron make the transition from ground state to the other energy level. So for that purpose, the energy required to excite an energy in H atom to its first excited state is equal to 1. Is the energy difference between these two states, E2 minus E1. Already we know that the energy of electron in nth orbit is minus 13.6 upon n square into z square. Or in other words, for hydrogen atom, the energy of electron in nth orbit minus 13.6 upon n square. Using this concept, E2 minus 13.6 upon 2 square, E1 minus 13.6 upon 1 square. Therefore, the energy required is 10.2 electron volt. Yes, the electrons get the 10.2 electron volt energy. So it makes the transition from ground state to the first excited state. Similarly, the energy required to bring the electron from the ground state to the second excited state is equal to 3. Therefore, E3 minus E1. So here the energy required is 12.9 electron volt. And the energy required to bring the electron in third, fourth, and so on, the final is infinite state, are 12.75, 13.06 electron volt, and 13.6 electron volt respectively. Clear? Thus, the minimum energy required to excite an electron, or the minimum energy required to bring the electron from ground state to the other excited state is known as the excitation energy. So that is the discussion about what is the ground state, ionization energy, and excitation energy, and also we do the graph of energy level. Clear? Then just we discussed about the ionization and excitation energy. Now, if the electron returns from an excited state to the lower energy state or the ground state, right? The photon is emitted. The photon of the energy equal to the energy difference between excited state and ground state, right? So what is the energy difference? According to that, the photon of this energy is emitted in this process. Again, when the electron, that is the ground state, there is the n is equal to second orbit, n is equal to third orbit, 4, 6, and so on. And last is the infinite orbit. Now, the n is equal to second orbit is known as the first excited state. N is equal to 3, third orbit is known as the second excited state. N is equal to 4, that is known as the third excited state. Just we discussed before in the discussion of excitation energy. When the electron makes the transition from ground state to the first excited state, the energy difference is 10.2 electron volt. Right? So 13.6 minus 3.40, that is the 10.2 electron volt energy. When the electron absorbs this energy, so it makes the transition from ground state to the higher energy state, first excited state. That means the second orbit. Similarly, when it gets the energy equal to the energy difference between the ground state and second excited state, that means the third state, E3 minus E1. At that time, it makes the transition from ground state to the second excited state. So there is the energy level diagram, or the energy diagram for the hydrogen atom. Now, the electron not remain for the long time in higher energy state. Within the 10⁻⁻8 second, it makes the retransition from higher energy level to the lower energy level of the ground state. So, if the electron return from an excited state to the lower energy state, that means from first excited state to the ground state or second excited state to the ground state and vice versa. So, the photon is emitted having the energy equal to the energy difference between these two states is emitted. Now, thus an excitation of H atom increases, that is, the N increases, the value of minimum energy required to free the electron from the excited state decreases. So, what is that? In excitation of H atom increases, it means the number of orbit N is going to increase, so energy is decreased. Therefore, the value of minimum energy required to make the electron free from the excited state is also decreases. To remove the electron from the ground state, we require the 13.6 electron volt energy. Now, when the electron is in first excited state, at that time it requires the 10.2 electron volt energy. So it has the energy in second excited state is minus 10.2 electron volt. So 10.2 electron volt energy is required to make the electron free from first excited state. So that is represented by this. As the increases, the value of minimum energy required to make the electron free from the excited state is decreases. Thus, here the equation En is equal to minus 13.6 upon n square electron volt. As the quantum number n increases, the energy difference between the two successive energy levels decreases. We have the equation of energy of electron in nth orbit minus 13.6 upon n square electron volt. As the n increases, number of excited state or the number of orbit increases, or the quantum number increases, the energy difference between the two successive energy level decreases. These two successive decreases. Right? The energy level for stationary state of hydrogen atom is shown here. So there is the excitation energy and ionization energy and energy level of the hydrogen atom. Right? Okay. After that, we start our discussion about atomic spectra. In atomic spectra, first, what is the emission line spectra and absorption spectra? First thing, what is the spectrum? Either the emission or the absorption spectra. Generally, we know that when at present in the packing, right, food pack or the any packing, at present we obtain the barcode. So this type of the barcode is the same as the spectrum. Here the different vertical lines are shown. Dark with the white thickness, second is the very sharp. So this type of the different lines are shown, that is known as the spectrum. Here are two types of the spectra. One is the emission line spectra and second is the absorption spectra. So what is the emission line spectra and absorption spectrum or the spectra? For that purpose, each element emits the radiation with the different wavelength depending on its temperature. Each and every object or the element emits the radiation with the certain or the different wavelength according to its temperature. As the temperature increases, so the wavelength of radiation is also going to change. Right? So hence, each element has the characteristic spectrum of radiation which it emits. So, for each element has the particular characteristic spectrum of radiation which emitted by this element. Again, each element emits the radiation with the different wavelength depending on its temperature, and hence each element has the characteristic spectrum of radiation which it emits. Now, when an atomic gas is excited at lower pressure by passing an electric current through it, in atomic gas as we pass the electric current through it at the low pressure, the emitted radiation has the spectrum having a certain wavelength only. So what's happened? Yes, the electric discharge passing through the atomic gas, and we obtain on photographic plate whatever the light is passing through the gas and what is the transmitted light. At that time, in this spectrum, the certain wavelength are obtained. This spectrum is known as the emission line spectrum. So whatever the photograph is obtained with the certain wavelength, that is known as the emission line spectrum. Emission line spectrum of any gas is studied to identify that gas. What is the importance of the emission spectrum? Emission spectrum, or from the study of the emission spectrum, we can identify any gas. Okay. Again, what is the emission spectrum? When an atomic gas is excited at low pressure by passing an electric current through it, the emitted radiation has the spectrum having a certain wavelength. This spectrum is known as the emission line spectrum. That means, yes, there is the atomic gas is filled, electric discharge is passing through this gas, atomic gas. So whatever the light is coming out from this gas is incident on a photographic plate. So here the lines are obtained according to the certain wavelength. So that is known as the emission line spectrum. The study of this emission spectra is useful to identify the gas. Here in figure, the spectrum emitted by the atomic gas, atomic hydrogen, is shown in the figure. Again, the spectrum emitted by atomic hydrogen atom is shown in the figure. Here the first line represents the Lyman phase, second line, this portion of the line represents the Balmer phase, and last is the Parsons phase. We also discuss in later the different shades of the spectrum, Lyman, Balmer, Beckett, Hahn, and also the Parsons. Now, what is the ionization? What is the absorption spectra? Emission spectra is this: in an atomic gas at lower pressure, as the electric discharge is passing. So in the spectrum, the certain wavelength obtained only. This spectrum is known as the emission line spectrum. Now, what is the absorption spectra? When the white light passes through a gas, why the white light, not the other light, yellow light, white light, blue light, green light? Because the white light is the combination of all the wavelengths. There is the electromagnetic radiation. In this white light, all the wavelengths are included. When the white light passing through a gas, in transmitted light, the certain wavelength which is characteristic of the gas are missing. That means are absorbed. So the some black lines appearing in the spectrum, of scattered light. when the white light or the bulge of the white light is passing through the atomic gas. According to the characteristic of the gas, this atom of the gas absorbs some wavelength of light. So this wavelength of light is absent in transmitted light. So what are the wavelengths are absent? At this place we obtain the black light. We obtain the black lights. And whatever the spectrum is obtained, that is known as the absorption spectrum. The spectrum produced by this dark light is called the absorption spectrum of the material of the gas. Right? Again, when the white light is passes through a gas, so in transmitted light, the certain wavelengths are missing, which is characteristic of the atom are absorbed. So some black lines is appearing in the spectrum of scattered light. The spectrum produced by these black lines is known as the absorption spectra of the material of the gas. Now, what is the difference between the emission and absorption spectra? Emission spectra is that in atomic gas at low pressure, as the electric discharge is passed. So, due to the excitation of the atomic gas, the certain wavelength are emitted by, or the light of the certain wavelength are emitted by the atomic gas. And according to this emitted light, here the lines are obtained, that is known as the emission spectrum. While in absorption spectra, when the white light is incident on atomic gas, according to the characteristic of atomic gas, the some light of the particular wavelength are absorbed by the atom, because the light is the bunch of photon having the energy. This energy is absorbed by the photon or the atoms of the gas. Therefore, what is the transmitted light? After passing the gas, whatever the light is obtained, in this obtained light, the some wavelength are missing. At the place of the missing wavelength, in photographic plate, we obtain the dark or the black light. This spectrum is obtained, that is known as the absorption spectrum. Clear? So, there is the emission and absorption spectrum.